Hello there, and welcome to the Sleepy Science channel. Tonight we drift into a world so tiny and ancient it makes everything else we know about life feel like a clumsy afterthought. Microbes slip through every corner of the planet, from the quiet air brushing your cheek to the deepest layers of Earth that sunlight will never touch. They invade, transform, and casually break the rules of nature like mischievous toddlers no one can catch. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Now, dim the lights. Maybe turn on a fan for that soft background hum. Within a single droplet of water, entire empires rise and collapse before you've even taken a sip. On the surface of a leaf, bustling microbial highways pulse with silent traffic. In places where life should absolutely give up boiling springs, frozen deserts, the inside of rocks microbes flourish anyway, painting hot springs with neon colors and carving patient signatures into stone. They hold secrets older than mountains, all tucked inside structures too small for your tired eyes to see. If you enjoy drifting through these quiet scientific lullabies, feel free to like, subscribe, or leave a sleepy little comment below. It helps wandering thinkers find their way here, one drowsy traveler at a time. For now, take a slow breath. Let your eyelids soften. Allow your thoughts to float gently as we step into the soft, humming world of microbes. Let's begin. Microbes were the first organisms bold enough to edit Earth's atmosphere. Long before forests swayed or fish darted through oceans, tiny cells were rewriting the chemistry of the sky. Early lineages discovered sunlight was basically free energy. Just grab water, crack it open, and save the pieces for later. The leftover oxygen reacted with minerals, staining ancient cliffs with dramatic rust stripes still visible today, like cosmic graffiti from another era. Slowly, oxygen began to accumulate in the air and seep into the seas, turning a world once suited for bizarre alien metabolisms into a paradise for oxygen-breathing life. Many earlier microbes panicked and scurried into weird little corners of the planet where oxygen couldn't bother them. Others adapted, inventing biochemical tricks impressive enough to make modern engineers reconsider their career choices. Over eons, that invisible shift in the sky paved the way for muscles, brains, and eventually you falling asleep to science videos at 2 a.m. Some microbes, in their infinite creativity, decided that breathing oxygen was too mainstream. So they breathe metal instead. To them, a chunk of iron or manganese isn't a rock, it's a cozy terminal for all the electrons they cough up while eating. Instead of passing those electrons to oxygen like we do, they hand them off to metal atoms, quietly exhaling rust into existence. It's recycling, but dramatic. Certain species glue themselves directly onto mineral surfaces, pushing electrons through specialized outer structures like microscopic electricians. Others toss out tiny molecules that ferry charges between cell and stone. In the process, they tweak the minerals around them, deciding whether metals remain locked in place or dissolve into water. This subtle dance can trap contaminants, stabilize uranium, and bury carbon. In labs, similar microbes are even persuaded to produce electrical currents, living batteries humming along on metal-breathing metabolisms. And then there are microbes that treat crude oil like an all-you-can-eat buffet. To many marine bacteria, an oil spill isn't a tragedy, it's brunch. Their enzymes latch onto long hydrocarbon chains with the enthusiasm of someone finally opening a snack drawer. They chop the molecules into smaller bits, pull them inside, and burn them for energy with zero guilt. Somewhere in the ocean, tiny cells are cleaning up messes we made, one oily mouthful at a time. Different strains of microbes are like nature's little engineers, each one specializing in breaking down specific types of hydrocarbons. When oil spills hit the ocean, these microscopic munchers spring into action, transforming invisible patches of water into buzzing feasts of activity. They thrive on heavy tars, medium oils, and lighter components, devouring the mess left behind. While they can't completely erase the harm done to oceans and wildlife, they sure do speed up the cleanup, proving that even the tiniest of organisms can tackle big problems. But let's not stop there. Some of these little guys kick it in the hottest, most acidic environments imaginable. Picture this: pools bubbling with volcanic gases and air that smells zesty like rotten eggs. Despite this inhospitable scene, certain microbes flaunt their vibrant pigments, which protect them against the fiery surroundings. Equipped with super-stable proteins and membranes that don't melt even at boiling point, they thrive on sulfur or iron instead of sunlight. These resilient microbes give us a clue that life might just kickstart in extreme conditions, serving as living examples of how chemistry under high heat fuels life in the most surprising ways. Now, if you descend deeper into Earth's crust, another community awaits. Far removed from sunlight, underground microbes cling desperately to life within solid rock. Living in tiny pores and fractures, they feast on the energy slowly leaking from the planet, like hydrogen from water-rock interactions. Their pace is leisurely, dividing only once every geological epoch. As they munch on minerals, they leave behind faint imprints that geologists can later recognize, bridging the gap between lifeless stone and living organisms. Who knew the rocky depths could harbor such a persistent, quiet life? Ever heard of the microbes that are total survival ninjas? These remarkable bacteria laugh in the face of radiation that would obliterate most living things. Instead of dodging the damage, they've mastered the art of rapid DNA repair. Their fiery inner life is all about creating multiple tightly packed copies of their vital DNA. When disaster strikes, their repair proteins swoop in, comparing strands and stitching everything back together after a radiation blast. It's a nerve-wracking dance. One slight misstep, and they could end up hapless wrecks, but they adapt like pros. These tough little microbes stockpile antioxidants and protective molecules, limiting the fallout from the high radiation environment. It's like living in a post-apocalyptic movie, yet they thrive. Their robust nature might just hint at life's potential existence in the most hostile of territories, whether on Earth's surface where cosmic rays rain down or in nuclear hotspots that could scare away lesser organisms. Who would have thought that life could not just exist, but flourish in hostile environments? As we dive deeper into the hidden world of microbes, it becomes clear that they are astonishingly adaptable. From scorching volcanic vents to the icy depths of rock, these little critters prove that life could indeed spread beyond Earth as well. Other rocky planets might just hold concealed habitats, waiting for human eyes to discover them. Their ability to persist under drastic conditions challenges our perceptions of life itself, hinting at a larger narrative, an epic tale of resilience, determination, and the relentless connectivity of life throughout the cosmos. In the realm of microbial wonders, some of these tiny prokaryotes have mastered the art of hibernation for millions of years. In the mystical salt crystals from ancient deposits, microscopic cells lie in wait, curled up in microscopic pockets of fluid, preserved like tiny treasures from epochs long gone. Deep in the permafrost, these resilient little critters have found a way to survive in frozen ground, putting their metabolism on a snooze button like a bear in winter. Protective proteins and sugars act like cozy blankets, stabilizing their structures, while water transforms into a glassy state, wrapping the delicate components in a protective shell. Fast forward to when conditions get a bit more hospitable, maybe a thaw or a good old rain shower, and voila! These dormant microbes wake up, stretching their little cellular muscles, and are ready to rejoin the living world. In sneaky lab experiments, scientists have managed to coax some of these microbial giants back into action, watching in amazement as they start to divide and conquer after their eons of slumber. This remarkable ability challenges our conventional understanding of life, creating an intriguing crossroad between biology and geology. Who knew that dirt and ice could be such treasure troves of microscopic surprises? But wait, the microbial adventures don't stop there. Some of these amazing little beings have taken to the skies, soaring high in Earth's upper atmosphere. Imagine tiny passengers hitching a ride on dust, sea salt, and soot, surfing invisible winds that carry them across continents. Up there, the air is as thin as a pancake and the temperatures can drop faster than you can find a warm jacket. Yet, these resilient microbes endure, protected by colorful pigments and tough cell walls that help them withstand the challenges of dehydration and cold. What's even cooler? These airborne microbes can play a role in weather. Just like plants drop seeds, these little champions act as tiny seeds for ice crystals in clouds, helping water vapor freeze around them and influencing where rain might fall. When storms kick up, they return to the surface, splattering into new environments. Talk about global travelers. This is nature's subtle way of intertwining ecosystems and a reminder that life is often more connected than we realize. And if you think the adventure ends at the atmosphere, think again. Some microbes can brave the vacuum of space like cosmic daredevils. Experiments on the exterior of spacecraft have exposed these hardy spores to all sorts of mayhem. No air, extreme temperature swings, and ruthless solar radiation. While most organisms turn into cosmic dust, a few tenacious cells hunker down, shielded in cracks and crevices, enduring the harsh conditions with their thick membranes. When they finally return to Earth's climes, they spring back to life, as if waking from one intensely wild nap. This astounding resilience doesn't mean life is likely zipping around between planets, but it keeps that possibility on the scientific table as an exciting notion. Plus, it serves as a gentle reminder to engineers that these microscopic hitchhikers can be quite the stowaways on spacecraft. And let's not forget about the origins of photosynthesis, an ancient trick borrowed by microbes long before the first plant unfurled its leaves. These tiny cellular pioneers captured light energy in primordial waters, weaving intricate networks of pigments and proteins to harness sunlight. Some bragged about using hydrogen sulfide or iron, painting the oceans in vibrant hues, while later forms discovered the art of splitting water, leading to the ultimate game changer, oxygen. This pivotal moment catapulted Earth's evolution, proving that sometimes the smallest beings can have the biggest impacts. Once upon a time, a group of microscopic pioneers got busy innovating with a molecular toolkit so nifty that it eventually led to the formation of chloroplasts in modern plants and algae. Thanks to endosymbiosis, these tiny champions partnered with one another, creating a grand alliance in ancient waters. So, every time you look at a green leaf, remember it holds an echo of those ancient microbial shenanigans that took place under primordial lights. Meanwhile, other microbes decided that living in cozy homes was the way to go. These ambitious architects began crafting stunning crystal structures in mineral-rich waters. Layer by layer, they channeled their inner builders, solidifying minerals into delicate cages and intricate patterns reminiscent of tiny cathedrals. Talk about creativity. They knew how to position themselves to soak up light while keeping pesky predators at bay, proving that even in the microbial world, style matters. Now, here's where things get electrifying. Some of these crafty microbes developed a super cool skill. They found ways to generate electricity. As they munched through organic materials, they decided to share their excess electrons with the external world, rather than just dumping them on dissolved chemicals. It's as if they set up living electrical circuits right inside mud or sediment, transforming their metabolism into a steady source of energy that would make any power plant envious. But wait, there's more. When toxic waste seeped into the soil, a special task force of bacteria stood ready, armed with metabolisms designed to tackle the nasties. These microscopic heroes captured toxic metals and complex chemicals, transforming them into harmless forms that could no longer wreak havoc. Some turned mercury into something less troublesome, while others managed to confine uranium into stable minerals. This dynamic cleanup crew worked quietly, reminding us that even the most damaged environments can host incredible feats of molecular craftsmanship. And let's not forget about their fierce defense strategies. In densely packed soils and thriving biofilms, competition for nutrients is fierce, and these microbes don't shy away from preparing for battle. They produce natural antibiotics to safeguard their territory, ensuring they can snack on nutrients without becoming someone else's next meal. Talk about a microbial turf war with some impressive arsenal. In this enchanting world of microbes, it's evident that life is full of surprises. Each layer of complexity, from crystal building to electric currents and toxin fighting tactics, paints a vibrant picture of the role microorganisms play. With their cunning skills, they don't just survive. They transform, innovate, and contribute to the very fabric of their environment, showing us how seemingly simple life can indeed have profound impacts on the planet. Microbes are the unexpected combatants in a hidden war, wielding chemical weapons like miniature ninjas in the soil. These crafty little organisms produce potent molecules that disrupt the enemy's cell walls, ribosomes, and metabolic pathways. It's like they have their own version of warfare, leaving behind a tidy plot of land for themselves to thrive. Interestingly, many modern medicines owe their existence to these microbial skirmishes, plucked from the soil-dwelling actinomycetes and their harmless allies that engage in this microscopic chaos. In the natural world, these chemical skirmishes are less about total annihilation and more about establishing turf. Picture it, rival species constantly adapting, creating dynamic borders in this captivating arms race. Each chemical challenge keeps microbes on their toes, urging them to evolve surprising defenses and innovative chemical tricks. This constant evolution morphs the underground battlefield into an unparalleled global hub for molecular creativity, influencing everything from ecosystem stability to the latest breakthroughs in medical research. But microbial communication takes on a whole new twist in the depths of the oceans and soggy soils. Some microbial communities are like the hipsters of the microbe world, using light signals to chat with each other. By producing special proteins that emit photons, these little critters create a soft glow that can send messages to neighbors equipped with the right receptors. When enough of these bacteria light up, it's a shimmering celebration of coordination. Think group movements, expansions, or even enzyme releases that benefit the whole clan. This light show isn't just for fun. It can attract larger organisms that help disperse microbes to new homes. Talk about subtle recruitment strategies. In marine environments, these glowing clouds transform into shimmering ribbons, twirling gracefully through ocean currents. Each flicker represents a tiny conversation in their world, revealing that communication extends into the microcosmic realm in ways that are both profound and almost poetic. If you thought navigation was only for sailors and hikers, think again. Certain microbes have their built-in compasses, with internal chains of magnetic crystals directing their movements. Similar to how a compass needle aligns, these crystal-laden cells orient themselves in lakes, soils, and sediments using Earth's magnetic field. They swim to their sweet spots, guided by an innate sense of direction, allowing them to locate just the right balance of oxygen and nutrients. This biological wizardry is possible because these tiny engineers deliberately accumulate iron, creating powerful magnetic crystals that help them navigate murky waters. This ability isn't just advantageous. It allows entire microbial communities to follow magnetic contours like secret pathways to optimal environments. Remarkably, fossilized records of these crystals have even provided insights into ancient magnetic fields, revealing that these minuscule navigators have been charting a course through Earth's magnetic compass for eons. Creating living mats that function as gigantic organisms is yet another remarkable feat of microbes. Picture thick carpets of microbial life rolling out across tidal flats, hot springs, and shallow seas, with each layer bustling with unique species. From capturing sunlight at the surface to breaking down complex molecules in deeper layers, it's a coordinated micro-movie happening right under our noses. As light shifts or currents flow, biochemical activity pulses through these living layers, mirroring the synchronized responses of larger creatures, proving that teamwork is the name of the game in their microscopic world. Over eons, mats crafted by microbes trap sediments and minerals, creating dome-shaped structures that stand the test of geological time. These little architects are responsible for some of the earliest known fossils, indicating that long before the rise of complex life forms, they were already messing around with shorelines and giving the ocean chemistry a makeover. Talk about inconspicuous contractors growing living landscapes, all while playing their own symphony of shared chemistry. These modern-day tiny titans are not just sitting around, either. Some can pull a fast one, rewriting their DNA like it's a weekend project. When the environmental heat is turned up, certain cells have mastered the art of genetic gymnastics, rearranging sections of their chromosomes with surgical precision. They snip, swap, and copy pieces of their genome, creating traits that are equipped and ready for all sorts of conditions. It's like a biochemistry magic show, where twist after twist keeps the essential bits intact but allows for a speedy makeover of the rest. The adaptability of these microbes is nothing short of mind-blowing. Imagine evolution not patiently playing the long game, but instead making bold moves in real time. Researchers are amazed to discover that these organisms can reconfigure their genomes within their own lifetimes. It's an impressive feat, a living throwback to the concept of survival of the fittest, but with a creative twist, showing us just how inventive microbial life can be when faced with uncertainty. Equipped with their own genetic toolboxes rather than immutable blueprints, these microbes are even social animals when it comes to sharing genes. Whether swimming in water, clinging to plant surfaces, or lurking inside animal bodies, they casually exchange bits of DNA, like passing notes in class. These tiny circular DNA rings can ferry over handy traits, such as the power to break down toxins or perform unique metabolic tricks. Through a casual mingling, certain microbes give and take like it's an evolutionary potluck. With these rapid gene exchanges, entire populations can quickly shift their abilities, breaking down the rigid boundaries of species. Scientists have been digging into all this, uncovering pathways that connect river microbes with soil dwellers or hospital bacteria with their wild counterparts. This interconnectedness reveals a communal aspect of evolution among microbes, where the spirit of invention thrives collectively, hinging on a willingness to embrace incoming genetic gifts. Evolution has never felt more like a team sport. Then there's the spectacle of floating cities formed by these ingenious microbes on the ocean surface. Picture tiny architects gathering up organic debris that drifts lazily up towards the sunlight. They whip together sticky molecules that bond particles into substantial rafts. Soon bustling mini-habitats emerge, with various species engaging in a shared economy, some capturing sunlight while others digest carbon compounds. These floating platforms become vibrant microcosms, promoting life that can travel great distances and quietly influence local ocean chemistry. Underneath the surface, these miniature rafts become bustling little markets, each playing a role in the ecosystem. Over time, they develop intricate food webs filled with bacteria, algae, and microscopic grazers, all held together by an invisible web of sunlight, surface tension, and just the right amount of microbial hustle. To the keen observer, these mini archipelagos are a testament to cooperation, life, and adaptivity, showcasing an astonishing spectacle of how microbes can turn both the underwater world and geological processes into their artistic playgrounds. Nature, effortlessly splendid. Who knew microbes could outsmart rock formation too? In the magical world of mineral-rich waterways, there exists a cast of microscopic heroes, tiny cells that specialize in transforming dissolved ions into solid stones. Think of them as the ultimate construction workers, crafting intricate structures where calcium, magnesium, and iron come to rest, forming dense clusters. As these busy microbes release organic molecules acting like tiny building guides, they help crystallize the ions into stable shapes, stacking layers until solid grains, nodules, or crusts emerge, all while lending a hand to Mother Nature in her quest to shape coastlines and caves. In coastal zones, these microscopic communities are like nature's architects, creating hardened layers that stabilize the sediments while shaping shorelines over time. Meanwhile, underground in dark caves, they craft delicate mineral curtains and twisting branches where the dripping water meets their miraculous chemistry. Though at first glance these formations may seem purely mineral, a closer inspection reveals their biological fingerprints, quietly showcasing how life can influence geological processes with small but mighty chemical nudges through the eons. Some of these microbial powerhouses go a step further, turning carbon dioxide into pure biomass with impressive efficiency, more so than your average plant. Deep within riverbeds, hidden mats, or specialized lab cultures, these little dynamos don't need leaves or chlorophyll. Instead, they have nifty molecular machines that shuttle carbon through turbocharged chemical loops, gripping and reshaping molecules with precision while wasting little energy. Whether it's harnessing sunlight with unique pigments or thriving in darkness, these microbes recycle carbon in places where vegetation is a rare sight, demonstrating their ancient worldly wisdom in the carbon cycle. But hold on to your hats, because some of these microbes are producing natural plastics inside their very cells. Imagine bacteria crafting large molecules that act just like soft plastics, storing energy as smooth granules nestled within their cytoplasm. These little beads are a nifty survival reserve that comes in handy when life gets tough. When conditions improve, they transform this stored plastic back into energy or growth materials, proving that evolution has outdone itself by creating materials echoing human inventions, all through gentle biochemical processes. Now, let's dive into the chilling realm of glacial ice, where specialized microbes manage to thrive in frigid conditions. Within tiny pockets of liquid that defy freezing even when temperatures drop to unbearable lows lie these resilient cells. They hitch a ride on nutrients delivered by ancient snowfalls, but have the amazing ability to slow down their metabolism to a crawl. They work quietly, repairing any damage from the cold while maintaining the necessary mechanisms to spring back to life once the world warms up. Some of these icy residents are smart cookies, producing protective proteins that prevent ice crystals from turning into jagged horrors. Others are savvy enough to generate pigments that shield them from harmful UV light filtering through the layers of ice. It's a tenacious existence, but these microbes are the epitome of resilience, showing us how life can adapt to even the most extreme circumstances while leaving a path of stunning biological wonder in its wake. Who knew the minutiae of microbial life could be so outrageously captivating? Glacial adventures are an unexpected thrill ride for some microscopic hitchhikers sliding down frozen highways. As glaciers trudge their way through time, they carry microbial life along, encased in ice like tiny little time capsules. These hardy microorganisms can fix their broken DNA with remarkable precision, showing a superhero-level resilience. While most organisms flail when their genetic code is damaged, some possess elaborate repair systems that can reconnect shattered strands with remarkable dexterity. These diminutive helpers meticulously keep multiple perfect copies of their genomes handy, comparing the damaged bits to the unscathed versions. When DNA gets tangled up in knots, specialized proteins swoop in to tidy things up, sorting the fragments back into their rightful order. Talk about a neat freak. They're like the ultimate repair technicians, dodging oxidative stress to ensure repairs go smoothly, keeping mutations at bay even in the icy embrace of their glacial home. Not just icebound superheroes, some of these microbes are the unsung heroes of polluted lands, munching on nuclear waste like it's a gourmet delight. Deep in contaminated soils and underground tanks, these specialized microbes work their chemical magic, transforming toxic metals into less harmful forms. They grab hold of elements like uranium, shifting their chemical states and trapping them in sediments, reducing the risk of unwanted water pollution. Imagine a superhero team taking on the toughest environmental villains. These microorganisms are right out of a microbial Avengers flick. As if that weren't enough, some microbes thrive in deep darkness, feeding off the hydrogen gas seeping from Earth's belly. In these subterranean realms, where sunlight is a myth and organic material is as scarce as unicorns, these clever microbes congregate near rock fractures. They've got a hydrogen-powered energy party going on, splitting the gas into protons and electrons to fuel their growth and repair needs, creating a vibrant ecosystem fueled by geological processes. It's like they're living in an underground energy factory that never runs out. This newfound microbial party throws open possibilities for understanding life beyond our blue planet. Researchers speculate that similar communities could exist beneath Martian soil or ice-covered moons, where water and rock dance in cosmic harmony. The idea that life could thrive far from sunlight gives us hope that the mysteries of the universe might be just a rock fracture away from discovery, waiting to be explored by curious minds and adventurous hearts. And if that isn't impressive enough, consider the incredible life forms that flourish around deep-sea vents, where the pressure is a heavy blanket and temperatures hit scorching highs hotter than boiling water. Here, intrepid microbes gather near these dazzling mineral-rich plumes that burst forth from the seafloor. They're resilient little party-goers, thriving in extreme heat while showcasing nature's knack for innovation. In these oceanic depths, we find life that defies our expectations, adapting to thrive in environments that others would run from. Deep in the narrow, chilly bands of the ocean, a microbe revolution is quietly brewing. These tiny powerhouses cling to mineral surfaces while mastering the art of survival by feasting on hydrogen sulfide, methane, and metals galore. Unlike most proteins that flee from heat, their enzymes become the superheroes of the microbial world, remaining stable when temperatures rise. These hardy little critters are essentially the VIPs of volcanism, setting the stage for a thriving undersea ecosystem that larger creatures can't resist, feasting on the chemical buffet they prepare. Get this, some microbes have the talent to create perfect little mineral cubes. Talk about architectural flair. These diminutive wonders work diligently in soils and aquatic habitats, using their microscopic magic to shape mineral crystals into strikingly neat geometric forms. Iron and sulfur compounds are the go-to materials here. By concentrating these elements on their surfaces, they release organic molecules to crystallize in neat patterns, resulting in sharp-edged cubes. Each crystal is nature's art piece, a snapshot of the meticulous biochemical environment surrounding these tiny builders. They aren't just pretty shapes, though. These resilient microbial cubes often accumulate and form a protective armor around the organisms, shielding them from toxins and nosy predators. Long after these microbes have taken their final bows, their mineral grains persist in sediments, leaving a legacy that speaks volumes about their ancient presence. The elegance of these crystals reminds us of just how intricately microbes can steer the inorganic world, all while mastering local chemical gradients with finesse that's nothing short of spellbinding. Let's turn our gaze to a scene that's reminiscent of the coral reefs, but without the animals. In sunlit, shallow waters, some microbes are busy creating coral-like structures through lead communities. They secrete sticky substances that eventually solidify, binding grains of sediment into curious nodules and domes. Photosynthetic microbes take the spotlight in the upper layers, capturing sunlight while deeper layers work as diligent caretakers, processing nutrients from decaying cells above. Decades pass, and voila! Entire formations arise, stabilizing coastlines and playing with water flow like it's their job. And, let's not forget the ancient creatures, the stromatolites, those fossilized witnesses of Earth's early party. In today's world, you can still find modern equivalents in protected bays and lagoons, showcasing the magical ability of collective microbial efforts to mimic complex coral architecture, layer by precious layer. They're proof that teamwork truly makes the dream work even in the microscopic realm, where slow but steady progress can lead to environmental transformations. Feeling a little dark? Let's illuminate things, literally. Some microbes have developed the spectacular skill of bioluminescence, casting a glow in the depths of the ocean, in damp soil, and occasionally within the bodies of other animals. Picture this. Within these cells are enzymes that bring oxygen and organic compounds together, resulting in a controlled light show a dazzling shimmer rather than a frantic flash. Not only does this light look cool, but it also helps the microbes manage excess energy, preventing damage while adding a twinkling drama to their dark home. The impressive adaptability of these microbes doesn't stop there. Many can withstand extreme desiccation, clinging to exposed rocks and sun-baked desert crusts, while some brave souls endure prolonged stretches without a sip of water. Talk about resilience. These miniature marvels are not just fighting for survival, they're mastering life's harshest conditions with remarkable tenacity, proving that even in the driest and most unfriendly terrains, life can endure, adapt, and flourish. In a world where survival often feels like a game of hide and seek, microbes have mastered the art of enduring droughts by entering a specialized resting phase. Picture them snug in their protective coats, tightly wrapping their DNA and enzymes with proteins, almost like a superhero protecting their identity. Their cell membranes morph into resilient structures that can withstand the squeeze of life's most severe circumstances, where metabolism takes a snooze so deep you'd think they were in hibernation. Yet, they're ever ready, biding their time until the sweet kiss of rain awakens their lively antics once again. When that life-giving moisture returns, it's like a party for these microbes. Water seeps back in, gently coaxing the mysterious machinery of life to kickstart once more. This elegantly orchestrated dance can happen time and time again. Talk about resilience. It's no wonder that these tiny titans shape the ecosystems around them, thriving amid stone, bark, and crusty soils, dominating areas where nature can't make up its mind between wet and parched. Talk about having your cake and eating it too. And speaking of parties, some of these microbes form remarkable slime networks that are nothing short of dazzling. Picture them as tiny wizards working their way through challenging mazes made of damp leaf litter and decaying timber. In glistening sheets, these microbial collectives navigate their territory, detecting local conditions like nutrient hotspots and physical blockages, all while looking like a slow-moving flood of shimmering goo. Oh, the drama of growth. Where food is abundant, they thicken and sprout branches, but when faced with obstacles, they hit the brakes like a bewildered hamster. But the excitement doesn't stop there. Researchers have discovered that when these slimy connoisseurs are placed in structured environments, they create intricate patterns that reveal their shortest paths to food sources. No single microbe is plotting this strategy. It's the whole community collaborating in a living map that shifts in thickness and direction depending on the best pathway to nutrients. It's like urban planning, but on a microscopic scale, where dietary expressways are formed, helping industrious microbes navigate life like seasoned commuters. It gets even better when we consider the fascinating coordination taking place among some communities. Picture microbiological social gatherings where individual bacteria glide together as if they're part of some grand performance. They communicate using molecular signals, responding to nutrient gradients like synchronized swimmers. When food is in abundance, cells surge forward in waves, weaving together a beautiful ballet until they reach the coveted ideal zone. Then just like that, they gracefully slow down, ready to savor their feast. But wait, when resources dwindle, these little entrepreneurs kick off something astonishing. Clusters of cells band together, forming impressive structures reminiscent of fungi. While some convert into tough spores, others appear to sacrifice themselves in the name of collective architecture, all in a choreographed show that speaks of communication and timing. It's a touching reminder that even these tiny single-celled organisms can exhibit behaviors that hint at a grander evolutionary narrative towards more complex multicellular life. Yet, these crafty microbes have tricks up their sleeves, especially in the realm of evasion. To survive the host's immune defenses, certain bacteria play a high-stakes game of disguise, constantly changing their surface molecular patterns to escape detection. With moves like shuffling outer membrane proteins and swapping invariants hidden within their DNA, they're like a magician pulling rabbits out of hats. Others cloak themselves in sugar chains, blending in with their host's own tissues, cleverly misleading immune cells to let their guard down, creating a rather cozy setup. As if that weren't enough, some masterful microbes retreat into safe zones within their hosts, lying low and waiting for the right moment to re-emerge once the coast is clear. These stealth tactics allow them to maintain a low profile, only to spring back to life when conditions are right or when they have amassed enough numbers for a grand reappearance. The back and forth between host and microbe reveals a saga that spans ages, filled with surprising strategies that highlight just how ancient this evolutionary cat and mouse game truly is. In the microscopic realm, a quirky dance unfolds among microbes as they cleverly adapt to one another's presence. Picture this. Certain crafty microorganisms decide that breaking down complex food molecules is just too much work. Instead, they play the role of energy parasites, sneaking next to their industrious neighbors and tapping into the electric vibes generated by those hard-working cells. It's like they're borrowing sugar from a neighbor, but on a much, much smaller scale. With specialized membranes, they link up directly, allowing electrons to flow freely from donor to thief, keeping the metabolic party going without any conventional trade. As these little rascals forge connections, they begin to blur the line between individuality and community. Imagine long chains of cells huddling together, sharing electrons like a power-sharing cooperative. In this electrifying environment, the hierarchy twists and turns because some energy thieves know how to drain power more efficiently from certain neighbors. Thus, the microbial community transforms. It's not all about competing for food or real estate anymore, as the invisible currents of life shift to the forefront of these tiny turf wars. In other parts of the microbial universe, some of these sneaky microbes create their own cozy bubbles. Picture them in muddy ponds or marshy spots, where they secrete a gooey substance that eventually turns into a spherical fortress. These bubbles are like microbial homes, soft yet resilient, that regulate their internal world despite the chaos outside. With stable pH levels and salt concentrations, the inhabitants have a fighting chance against toxins trying to infiltrate their cozy sanctuary. Predators searching for a snack will find it trickier to engulf these encapsulated critters, making life a bit safer for the bubble dwellers. As generations pass, these bubbles can become intricately complex, incorporating minerals and reinforcing their protective shells. When the environment turns favorable, the microbial residents are ready to escape. They might create tiny openings in their gel-like matrix or simply burst free, sending a tiny colony splashing into more welcoming waters. This lonely little bubble is proof that even the tiniest of cells can build their own home sweet home with nothing but secreted goo and a bit of cellular ingenuity. Unexpectedly, some of our microscopic friends take their talents to the weather front lines. These savvy microbes have a knack for influencing the clouds by flinging themselves into the atmosphere. As air currents carry them aloft, they hitch a ride in water droplets precariously hanging in the balance. Some of these moisture-loving microbes boast proteins on their surfaces that can kick-start ice crystal formation, even while the temperature is still behaving itself. This invites a chain reaction, transforming droplets into burgeoning snowflakes that fall gracefully back to Earth, delivering wet surprises while bundled up with microbial stowaways. There's also a gang of microbes that feel right at home in the unlikeliest place: volcanic glass. Picture this when lava meets cold seawater or cools rapidly in the air. It forms a glassy rock riddled with tiny micro cracks. Over time, little microbes sneak into these nooks and crannies, settling down for a cozy feast on the minerals trapped within. In this bizarre underwater habitat, they draw energy from various chemical reactions, working their magic on the bits of glass surrounding them, gradually excavating intricate tunnels that map their journey through the solid world. Now, these ingenious life forms may be small, but they wield enormous influence in their microscopic kingdom and beyond. From coordinating their energy thievery to crafting cozy bubbles and even messing with the weather, they illustrate just how interconnected life can be, where competition, community, and creativity all play a role in the vast microbial tapestry. So next time you glance at a pond or shake off a snowflake, remember, these unseen heroes are spinning the story of life in ways that are both fascinating and, at times, downright funny. Under the microscope, we find fascinating micro-galleries, resembling nature's very own art collection far beyond mundane chemical weathering. Ancient oceanic crust samples exhibit these dazzling structures, suggesting that microbial residents have existed long before we graced the Earth. Surprise! That seemingly barren, fresh crust is actually bustling with life, engaging in a bit of symbiotic magic, helping to shift elements from solid rock into active, flowing fluids. Talk about a microscopic upgrade. Microbes aren't just cute, they're rather cheeky, too. Over time, they break down the very stone that monuments are crafted from. Think statues, temples, and gravestones that aren't immune to this tiny assault. These little critters gather where dust and moisture settle into tiny pits, eagerly releasing organic acids that nibble away at calcite and feldspar. As raindrops tumble down, they carry away dissolved ions like a thief in the night. And the shenanigans don't stop there. Some of these microbes produce dark pigments that soak up sunlight, gently heating stone surfaces like a tiny sauna. This tiny toast to warmth initiates cycles of expansion and contraction, gradually summoning up more microscopic cracks for future incursions. Certain mischievous species might even bind airborne particles into protective crusts, keeping moisture snug against the stone, ensuring their relentless chemical attacks continue with gusto. Decades turn into centuries, and the results are clear, sharp chisel marks gradually round out into soft contours, with crisp inscriptions fading into faint memories. It's like watching a Stone Age endeavor slowly morph into abstract art. Conservation scientists are on the case, meticulously studying these lively communities on our heritage stones. Their aim: to coax less harmful species into the spotlight while giving the aggressive ones a stern talking to. Oh, and let's not overlook microbes in extreme environments. In ocean trenches, they endure crushing pressures that would send human-built submersibles crying home to their mothers. Within the depths, these hearty microorganisms thrive, their membranes containing unique lipids that remain fluid under thick pressure. They're kind of like the superheroes of the microbial world, keeping their metabolic engines humming while everything else around them struggles for breath. Some of our little friends prefer sulfur, a delectable treat for them, but not so much for most life forms. In geothermal springs, Bright yellow sulfur deposits tell a tale of surviving against the odds. These microbes dive headfirst into the sulfur, turning it into a feast by stripping electrons and generating the energy they need. They reshape the sulfur into stunning sulfate crystal formations, effectively setting up their own dainty signature in environments so hot and acidic they'd make most cells melt away in despair. A few microbes go the extra mile by crafting hefty armor plates around themselves. Imagine tiny warriors donning suits of armor made from silicone or calcium carbonate. These plates are crafted using materials that the microbes meticulously collect from their surroundings, transforming them into a protective barrier. It's a testament to how industrious and clever these minuscule beings are, demonstrating that life can flourish in the most unexpected places. Inside their microscopic realms, specialized proteins work tirelessly to fashion minerals into spectacular shapes. Think dazzling discs, intricate scales, or star-like wonders that would make the finest jeweler envious. These carefully crafted plates come together, creating protective shells that act like tiny fortresses against predators, rough waters, and unexpected salt shifts. The symmetry and precision in these shells are so remarkable that scientists can identify long-lost species simply by studying their mineral remains, a fabulous feat of nature. It's like a game of hide and seek where the stakes are high. These natural armor pieces accumulate over time, creating sediment layers that eventually transform into geological formations. It's astonishing to realize that even the simplest of single-celled organisms can produce such complex structures using just minerals, proteins, and a touch of patience. Who knew that your average microbe was such a crafty architect? Moving on, some of these microbes have a unique method of getting around, by morphing their own forms. Forget muscles and legs. They slide across surfaces using a captivating choreography of expansion and contraction that ripples through their cell membranes. Picture this: networks of proteins pushing out in one spot while pulling back in another, akin to a soft, flowing dance, all guided by chemical gradients. This lets them waltz toward food while dodging toxins, nature's own charming little ballet. And then there are the trailblazers, literally. Some microbes leave behind trails of slime. This goo reduces friction and allows them to glide effortlessly over various surfaces like sediments, leaves, and even biofilms. Others, the clever little grapplers, extend temporary pseudopods that latch onto surfaces before they haul themselves forward, showcasing a level of coordination that would impress any seasoned athlete, albeit at a minuscule scale. But let's not forget the warriors of the microbial world. Some mischievous microbes hunt others with harpoon-like devices. These predatory bacteria are like the sharp-dressed assassins of the microscopic underworld, building spring-loaded tools that fire protein needles into their unsuspecting neighbors. When triggered, these molecular weapons extend with a speed that belies their size, piercing through membranes and injecting enzymes to dissolve defenses. Talk about being armed and dangerous even in the tiniest dimensions. In the ruthlessly competitive depths of their world, these tiny predators coordinate their attacks, especially in nutrient-scarce environments. The revelation of these molecular weapons has flipped the script on what we thought we knew about microbial warfare. After all, who knew such minuscule beings could wield tools for hunting and defending their territory? It's a tiny, yet formidable arena of battle. As if things couldn't get more fascinating, some microbes have mastered the art of trapping prey by transforming watery surfaces into gel-like entrapments. Imagine a predator that secretes long carbohydrate chains that expand dramatically, turning a fluid landscape into a sticky hazard. This ingenious method doesn't rely on toxins or speed, but on simple physics, immobilizing unfortunate victims, transforming them into snacks. Once caught, digestive enzymes begin their slow work, allowing the predator to feast effortlessly. Truly a unique strategy. These hunting zones culminate in the most astonishing teamwork, as various microbial groups maintain distinct gel layers, stabilizing their communities and controlling access to food. It's as if there's an entire bustling society within this microcosm, demonstrating that even the smallest of beings can wield incredible power over their environment, using strategies that rival the mightiest of predators. In fact, some of these hardy microbes even flourish in salt concentrations that would make the ocean appear tame. How's that for resilience? In the wild world of hypersaline lakes, where salt levels would make a regular cell curl up and weep, you'll find some super salty microbes living life to the fullest. These quirky little guys glow in bright shades of red, orange, and purple, thanks to their unique membranes and adventurous proteins. Instead of dodging salt like it's an awkward ex at a party, they invite salt ions to join their inner circle, allowing their insides to chill at a similar concentration to their salty surroundings, no shrinking required. You see, while most microscopic organisms would throw in the towel under such brutal conditions, these funky microbes rewrite the rulebook on survival. They not only manage to stay alive, but also add some intriguing colors and oddball chemistry to their extreme habitats. With pigments that act as sunglasses against the blazing sunlight that bounces off salt flats, these microbes remind us that life can be a vibrant spectacle, thriving in places we typically consider uninhabitable. Long live the salty superstars! And when you think things couldn't get more bizarre, meet the astonishing microbes living inside radioactive waste tanks. These little wonders have seemingly cracked the code to life in the most chemically hostile environments. Picture them squeezing through cracks and chilling on container surfaces while bravely facing radiation that could take out a traditional cell with ease. They possess stellar repair mechanisms that can fix broken DNA strands like their lives depend on it, because they do. While they can't zap away all dangers, they've got a flair for influencing the toxic cocktail around them. Changing the oxidation states of metals and impacting solubility, these resilient microbes might just assist researchers in managing the tricky waste streams they inhabit. Their surprising existence in such dire spots serves as a reminder that life can wiggle its way into the unfriendliest places, adapting to challenges we can hardly imagine. Venturing into a slightly more relatable environment, let's chat about the microbes that make our gut their home. These microscopic residents are the unsung heroes, or sometimes the sneaky villains of our internal world, affecting everything from digestion to how we muster up courage in stressful situations. They communicate with their hosts through a cocktail of hormones, neurotransmitters, and other compounds, shaping our responses to food, stress, and even social interactions. It's a tiny ecosystem bustling away, influencing behavior like a behind-the-scenes director in a blockbuster movie. But hold on a minute. Not all microbial influences are sitcom-worthy. Some microbes may manipulate their hosts to spread themselves around, making animals seek environments that facilitate their journey. This dance of influence reveals a complex relationship, showcasing that what we feel and how we act isn't solely dictated by our brains, but also by the countless little companions living it up inside us. Microbiomes, it seems, are the ultimate life coaches, whether we like it or not. Last but definitely not least, ever wondered how snowflakes form their intricate patterns? Well, it's all thanks to some crafty microbes floating about in the sky. These bacteria have mastered the art of triggering freezing by presenting special surface proteins that encourage water molecules to align into pretty ice sculptures. After hitching a ride on dust particles or leaf snippets, they ascend into the cloud party, spreading their frosty cheer and influencing snowfall patterns, especially in lush green areas. Each flake might just carry a little piece of their microbial maker, a delicate reminder of the microbiological magic that has a hand in the wonders of nature. Tiny cells whisked up by the wind have a magic way of orchestrating ice structures, turning landscapes into frosty works of art, replenishing rivers, and even influencing regional winter weather patterns. These microbial maestros are agile, transforming barren seasons into festive winter wonderlands. They float through the air, carrying with them the potential to change everything beneath their delicate, drifting forms. Nature's tiny architects bead together chains of ice, crafting designs that can leave us all in awe. Digging deeper into the world of wood, some remarkable microbes take on the role of nature's demolition crew, digesting wood more efficiently than the famed termite. Living in decaying logs and snuggled up in compost heaps, they partner with fungi to conquer even the toughest wood fibers. Their secret weapon? An impressive arsenal of enzymes that dismantle the rigid cellulose and lignin structures holding trees upright. With a swipe of their enzymatic wand, they transform solid timber into something more malleable, creating a culinary buffet of sugar and wood leftovers. As our tenacious wood-whittling microbes chomp through timber, the mighty transformation begins. Picture it, sturdy logs becoming lighter and airier, peppered with pockets for other critters to call home. This sneaky renovation is key in forests, where these invisible carpenters recycle carbon and nutrients back into the soil, providing fertile ground for new plant life. Without their diligent work, you'd find a mountain of fallen trees wreaking havoc on ecosystems, starving them of nutrients they desperately need to flourish. Some of the more flamboyant microbes go beyond just breakfast. They've got pigment tricks up their sleeves. Forget the standard greens of chlorophyll. These little artists dance with colors like pink, purple, and gold, soaking up light like there's no tomorrow. Some microorganisms have harnessed sunlight's energy using pigments that peek through the ordinary spectrum, thriving in dim depths of oceans where plants get all moody. They've created minimalist light harvesting systems that keep everything functional while blushing in the face of sunlight. Now, let's talk about the true survivors, the microbes that thrive in oxygen-free zones. Living happily in murky sediments, flooded soils, or cozy animal interiors, these little guys espouse their Bauhaus philosophy with elegant simplicity. Instead of relying on oxygen for fuel, they ingeniously substitute it with other electron acceptors. They go through a series of chemical maneuvers, producing gases like nitrogen or methane as their quirky byproducts. Without oxygen drama, they maintain a snugly reduced environment, continuing life as if oxygen was just a fad. Diving even deeper, we stumble upon microbial forests flourishing on the ocean floor. With a flair for the dramatic, these filaments and stalks rise from the depths like ghostly lush grass. These microbial communities come together like a rock band, with each filament acting as a supportive group of cells working in harmony. Some single cells, resting atop mineral stalks they formed, boost themselves into better water currents for a more favorable existence. It's a concert of life, all sung in harmony beneath the waves. Taken together, these microbial wonders remind us that life's canvas is painted with vibrant colors, odd compositions, and playful symphonies. They quietly nurture ecosystems, sculpt landscapes, and push forward the boundaries of what we know about survival. Who knew such small players could hold the keys to both ancient mysteries and modern solutions? Next time you see a peaceful forest or a calm ocean, remember that it's teeming with lively and witty microbial personalities working behind the scenes. Imagine gazing at a vast expanse of the seafloor, where unique structures peek above the ocean floor like a quirky ensemble of underwater trees. These formations, resembling sparse yet organized forests, aren't made of wood but are crafted from microbes, effectively creating a bustling ecosystem. Winding currents swirl between them, whisking along oxygen, sulfide, and organic matter, ensuring that nature's little engineers thrive together, munching on microbial films and contributing to the overall health of the seafloor environment. As these microbial forests grow and decay, they become the architects of change, reshaping sediments and influencing chemical flows between the seabed and surrounding waters. It's a remarkable example of how microscopic life can craft landscapes. Some ambitious microbes even build towering mounds that stand the test of time. In contrasting habitats like shallow lagoons and alkaline lakes, layered microbial communities work tirelessly, trapping sediment grains to form impressive domes that can reach skyward. Talk about careers in construction. Each day, these crafty communities engage in teamwork. Photosynthetic microbes create sticky substances that bind incoming particles together, forming a solid base. When night falls, the community shifts gears, processing the organic materials from the daylight hours and releasing gases and nutrients. With each global work cycle, new layers pile atop one another like a delicious lasagna, allowing the mounds to grow upwards and outwards over centuries. Remarkably, some endure as fossilized structures, capturing tales of environments long past. It gets even more exciting. Some microbes have taken teamwork to a whole new level, growing filaments longer than most animals. Researchers have found bacteria that link together in long chains, creating continuous living cables. This unique structure allows them to engage in impressive long-distance chemistry, overcoming the limitations of solitary bacteria. Imagine one end of the filament thriving in a sulfide-rich zone while the other enjoys oxygenated waters. Those adventurous little microbes are pioneers of connectivity. As these filaments extend through various microhabitats, they form a single organism, reminiscent of a circulatory system, bridging vast chemical worlds. This rewrites our expectations of what constitutes an individual organism. It's not just about one cell, it's about how these micro-collaborators operate as a cohesive unit. Their presence challenges our perception of individuality. They redefine teamwork on a microscopic level. Moreover, certain microbes become the ultimate habitat engineers, creating their own tiny ecosystems in water droplets or soil grains. By producing exopolymers, they mold simple surfaces into structured environments that support various organisms. Channels, pockets, and gradients characterize these engineered habitats, while metabolic byproducts from the founding microbes lure other critters into the mix. It's like throwing a party where every guest brings something to the table. The arrival of new inhabitants brings vibrant diversity to these micro-worlds, with each occupant thriving in its niche a mere micrometer away from the next. The foundational microbes benefit, too, with their neighbors taking care of waste or providing essential nutrients. Even in spaces minuscule enough for our eyes to miss, these microbial ecosystems work tirelessly, illustrating the complexity and beauty of life at tiny scales. It's a vibrant reminder, microbes are masterminds, shaping their world one layer at a time. Microbes are not just sophisticated party-goers, they're also savvy energy investors. Instead of sweating it out with transient chemical gradients, some crafty microorganisms create dense, energy-rich compounds as internal reserves. Think of polyphosphate granules and reduced sulfur globules as their energy savings accounts. Under the microscope, these bright inclusions dot the cytoplasm like glittering jewels representing stored power. When times get tough, like light dimming or food disappearing, these tiny titans break down their investments to release energy, all without splurging it as heat. When life throws them a curveball, such as changing light or the sudden disappearance of nutrients, these savvy microbes don't panic. They've got it all under control, smoothly managing their energy reserves like seasoned stockbrokers navigating Wall Street. This strategy gives them the flexibility to tackle sudden environmental changes, ensuring steady growth even when nature throws its highs and lows in their paths. Imagine them as microscopic rechargeable batteries, demonstrating that even in the world of microbes, smart solutions to fluctuating resources abound. But wait, there's more. Some of these unassuming microbes moonlight as environmental heroes, turning toxic metals into benign substances. Picture bacteria in wetlands and riverbeds as mini alchemists, transforming nasty metal ions from hazardous to harmless. They pull this trick by attaching metals to organic molecules or reducing their oxidation states, making them less mobile. It's like throwing a fancy party where the metals mingle and settle down as tiny crystals, safely trapped away. In return, these microbes may gain energy from their detox work, ensuring they get something out of their charitable deeds. Not only do these little wizards help by lowering the concentration of dissolved toxins like chromium and arsenic in water, but their feats have a rippling effect across ecosystems. The quiet, unassuming toil of these microbes protects plants and animals, showing that the coolest contributions often happen behind the scenes. Who knew that tiny microbes could be the unsung champions of maintaining balance in nature? They're shaping the environment in ways that would make even the most uninspiring environmentalists proud. Enter the herbivores, cows, deer, and others who have signed a lifelong pact with their microscopic buddies. These animals rely on dense communities of microbes in specialized stomach chambers to help them break down tough plant fibers. The microbes produce enzymes that turn cellulose into smaller, digestible sugars, which they then ferment into delicious organic acids and gases. These acids become the primary energy source for the host, allowing them to enjoy the benefits of a nutrient-rich diet without lifting a finger. This partnership thrives on a back-and-forth arrangement, as one group's waste becomes another's feast. Some microbes are particularly generous, converting nitrogenous compounds into forms that can be reused for building proteins, ensuring that herbivores thrive on diets low in ready-to-eat nitrogen. The symbiosis is so profound that neither partner could carry on its lifestyle solo. Herbivorous mammals become mobile microbial factories roaming the grasslands, fueled by their microscopic companions. And in the world of the bizarre, some microbes have figured out how to team up and create living cables. In muddy seafloors and waterlogged soils, bacteria band together to form chain-like structures that could give electrical wires a run for their money. Each strand consists of countless cells aligned end-to-end, wrapped in a shared outer covering for stability. These electrifying chains facilitate the travel of electrons over remarkably long distances, with one end buried deep among sulfides while the other stretches toward oxygen-rich waters above. It's a natural phenomenon that connects them in a unique dance of energy transfer. Imagine tiny microbes acting like an underground power network, zipping electrons through their microscopic bodies like they're on a biological express train. This playful yet profound connectivity allows for chemical reactions that no solo cell could pull off. As these little creatures stretch beyond their individual habitats, they create a living conduit wrapped around different environments, ensuring that all the players needed for their complex chemistry come together, sometimes from miles apart, no less. These microbial power lines do wonders when they get together in a big way. Far from being mere isolated entities, they operate on a grand scale, challenging the notion that small organisms must remain solo acts. They regulate the breathing of sediments, cycle nutrients, and control greenhouse gases like methane, which can escape from wetlands and thawing permafrost. Thanks to this teamwork, they help diminish methane emissions that would otherwise skyrocket, making the planet slightly cooler. Good news for Earth, if you ask me. Strangely enough, some of these microbes can even stop methane in its tracks before it has a chance to wreak havoc on the atmosphere. In various sneaky locations, including rice paddies and lake bottoms, they perform feats of chemical gymnastics. Some bacteria oxidize methane with a side of oxygen, transforming it into harmless carbon dioxide. Others are adept at working in oxygen-free zones, forming tight-knit teams with archaea, sparking a remarkable partnership that allows them to hand off electrons with pinpoint precision. While they're busy blocking those greenhouse gas bubbles from escaping, these savvy microbes create zones where methane levels dip drastically. Picture a cozy little bubble of gas being hugged tight by a microbial community, pumping the brakes on greenhouse gas emissions. The activity of these super tiny yet incredibly powerful organisms helps define the warming potential of wetland and freshwater ecosystems, showcasing that when you work together, you can change the game in profound ways. Miraculously, some microbes are equipped for life in the freezer, surviving the harsh, bone-chilling conditions of tundra soils and high-altitude lakes. These bad boys endure icebox cycles that would have other organisms crying for mercy. Their secret? Protective compounds that prevent ice crystals from forming inside them like tiny shards of glass. They've even got tricks up their sleeves, like releasing proteins that hold back the ice beast, keeping their delicate interiors flexible and intact when the cold hits. And when the temperature dips too low, these resilient cells have a master plan. Their metabolism quiets down to near silence, but, like tiny mechanics, they continuously patch up minor damages while frozen. With a little warmth, they thaw and spring back to life, like they just woke from the best cream-filled cake coma. This ability to withstand repeated freezing intervals opens up an exciting possibility. Life may exist in frozen realms beyond our planet, just waiting for a warm invitation to come back. Even crazier, certain microbes are clock watchers. A handful of photosynthetic bacteria possess internal clocks that tick in harmony with day and night. These proteins crank on and off rhythmically, staying in sync even without sunlight. They've developed an internal vibe that prepares them for the daily shifts, allowing them to harvest energy during the day and conserve it at night, like a microbial dance party, where everyone knows their cues. Researchers have even transplanted these biological clocks into other organisms, opening a treasure trove of insights into the timing of life beyond just plants and animals. Who knew tiny microbes were the true masters of rhythm? Scattered throughout soils, sediments, and water bodies, some crafty microbes have turned into nature's stonemasons. These tiny critters manipulate the minerals around them, drawing dissolved ions to their surfaces like kids to a candy store. By releasing organic molecules, they promote crystallization and create structured patterns. With every charming cycle of deposition, they produce tough coatings that grab hold of loose particles, binding them into one sturdy assemblage. It's like they're saying, There's no more room for weaklings here. Some of these microbial artisans even engage in a bit of mineral wizardry, precipitating iron or manganese oxides to form protective layers around biofilms. It's their way of creating cozy little hideouts from the hostile environment. In other scenarios, they skillfully guide mineral growth along preferred pathways, enhancing the strength of natural building materials. Over an extended time, these microscopic workers influence nodules, crusts, and pavements, fashioning landscapes in deserts and shallow seas. Who knew that the foundation of such grandeur lay in the hands, or rather, the cells of microscopic life? Let's not forget about those fabulous magnetotactic bacteria. These little marvels carry tiny magnetic crystals that serve as biocompass needles. In their underwater realms like lakes and estuaries, they diligently align the crystals into tiny chains. This arrangement points them in the direction of Earth's magnetic field, allowing them to swim expertly through varying oxygen levels. Bypassing tedious chemical gradient sampling, these savvy bacteria save energy while making it easier for them to find just the right depths to thrive. When the cells meet their demise, their magnetic remains leave behind trails that tell the stories of ancient magnetic fields and microbial communities. Talk about leaving a mark. And then there are the microbial artists creating floating blooms that can be seen from outer space. In oceans and expansive lakes, certain photosynthetic microbes multiply at lightning speed, transforming the surface of the water into a vibrant tapestry. Their swaths can be turquoise, crimson, or deep jade, shifting and swirling with currents and winds. Under ideal conditions, they're like nature's party planners, drawing nutrients from upwellings and capturing sunlight, transforming the water into a hub of life that nourishes zooplankton and fish. But let's keep it real, these microbial parties can occasionally turn into raging raves. Some blooms produce toxins or gobble up nutrients faster than they can be replenished, throwing ecosystems into chaos. That's where satellites enter the scene. From their lofty perches, researchers can track these blooms and observe the dynamics of their growth and eventual decay. It's a reality show for the planet's tiniest players and a reminder that even the smallest life forms can have a colossal impact. Lastly, we can't overlook the calming presence certain microbes impart on their ecosystems. Nestled in soils, plant roots, and aquatic communities, some microbes release soothing molecules that quell nearby organisms. This gooey goodness can calm stress responses in plants and meddle with the signaling systems of competing microbes, all while keeping tiny predators in check. It's like nature's little chill pills, fostering peace and cooperation. Plants thrive under this tranquil chemistry, better equipped to handle drought and toxic metals. Who knew microbes had such a knack for keeping the peace? Animals grazing on microbridge detritus might not realize they're munching on mood-altering compounds. These tiny, quirky influences weave a web of chemical connections that shape entire ecosystems. It turns out, microbes are like nature's tiny therapists, bringing calmness to chaotic environments. By subtly adjusting the chemical makeup of their surroundings, they help soften the harshness of nature. Who knew a microscopic organism could be the unsung hero of tranquility? But wait, there's more. These little bacteria also have a hand in plant growth. In the thin layer of soil-hugging plant roots, microbes hustle to release special chemicals. They're the silent coaches directing root systems to branch out, allowing plants to sip more water and gobble up minerals. Not only do they loosen up tight soil to make it easier for plants to grow, but they also arm their leafy buddies against pesky pathogens with antimicrobial agents. It's a friendship built on nourishment and protection. In this remarkable relationship, plants return the favor by leaking sugars and amino acids to their hard-working microbial partners. It's an exchange that fosters growth and success, just like a good team. Healthy fields bursting with these microbial communities are champions even in dire conditions. They illustrate the fact that plants aren't lone rock stars. They're part of a harmonious underground band, jamming together for survival amidst nature's challenges. Now, let's turn our attention to those clever little microbes that turn atmospheric nitrogen into a feast. Although the air is brimming with nitrogen, most living beings can't directly access it. Fear not. Certain microbes are equipped with enzyme systems that break down the stubborn triple bond of nitrogen molecules. They perform this magic inside specialized plant root nodules, converting nitrogen into ammonia, a yummy morsel that plants can munch on. It's a high-energy act that truly showcases the beauty of mutually beneficial partnerships. These clever arrangements hold sway over how quickly nutrients cycle through ecosystems and the productivity of soils. Some of the richest agricultural regions owe their bounty to long-standing collaborations between plants and microbes. These pint-sized chemists are crucial for maintaining the global food web. Without them, growth around the globe would face major roadblocks. Talk about a tiny but mighty influence on the world. But let's not forget the vibrant life in geothermal pools. Certain microbes, sporting catchy pigments, thrive in hot springs where mineral-rich water bubbles up from deep inside the earth. These colorful mats not only look stunning but also serve a vital function. Pigments protect microbial cells from heat and harmful UV rays. Just like a good suntan lotion, some pigments absorb harmful energy, while others are all about soaking up light for photosynthesis in near boiling conditions. Each hue represents a community thriving at a specific temperature range, nature's very own living rainbow. Moving on to the wild world of microbial predators, some bacteria take a more sinister approach. These pint-sized hunters can invade and utterly dismantle other cells. With stealthy tactics, they squeeze through breaches in microbial defenses or release enzymes to soften their outer membranes. These clever predators don't just snack, they devour. In the grand scheme of insectivorous dining, who knew the microscopic world was also filled with these small but terrifying predators? Like a horror movie for microbes, it's a cutthroat and incredibly essential part of ecosystem dynamics. Inside the microscopic world, predators work tirelessly, mastering the art of cellular sabotage. They reprogram host cells with the finesse of a tech-savvy Grinch, halting vital functions and breaking down sturdy defenses. As the host grows weaker, these crafty predators unleash a battalion of enzymes, munching through complex molecules until they're nothing but tasty bits. It's a race against time as they gobble down nutrients, expanding like a balloon at a birthday party until the poor host can't take any more and bursts, releasing new predator cells, ever ready for fresh feasts. This high-speed cycle of destruction is so effective that entire groups of prey microbes can disappear in just hours. Remarkably, these tiny hunters aren't the villains of the microbe world. They actually play a vital role in keeping microbial communities balanced. Thanks to these stealthy predators, no single species can rule the microscopic roost for too long. The endless game of survival sparks innovation, pushing prey microbes to invent quirky new defenses and strategies, proving once again that even in the microbial realm, it's survival of the fittest. Navigating through their environments like tiny explorers, some microbes have the incredible ability to smell out chemical trails. Talk about a superpower. In watery worlds, bacteria cleverly ride the currents, letting the sense of amino acids or sugars guide them towards tasty food or a swift getaway from danger. With highly sensitive receptors, they embark on a fine-tuned dance, constantly adjusting their path with little bursts of movement, creating smooth, flowing lines of life. In groups, these savvy microbes follow shared gradients like a conga line headed straight for a nutrient buffet. In more crowded habitats like root surfaces or biofilms, these little navigators become true master architects, weaving complex trails through tight spots with pinpoint accuracy. They can even sense subtle changes in chemical releases, redirecting thousands of their buddies in an instant. It's like an impromptu traffic reroute, powered by nature's simple yet effective guidance system. The charming aspect of it all? This intelligence arises from basic sensors reacting to their environment, continuously adapting and evolving over time, all part of life's intricate dance. Venturing beyond the shallows, some microbes play a role in redistributing essential elements across vast oceans. These microscopic drifters are like the ocean's delivery service, absorbing trace metals and nutrients as they bob through different depths. Every time they excrete waste or float to an untimely demise, they scatter their precious cargo far and wide. When blooms occur at the surface, they gather carbon and send it packing down into the depths, as if nature intended a grand carbon surprise party far below. Even in polar regions, microbes are busy influencing marine food webs. When the ice melts, they release rare compounds that send ripples of change across hundreds of kilometers. It's like a seasonal gift-giving spree, where the entire ecosystem benefits from their generosity. This ongoing microbial movement functions as nature's conveyor belt, shifting nutrients and elements across latitudes and depths, vegan style. This remarkable redistribution is crucial for sustaining entire marine ecosystems, constantly fine-tuning the global ocean's chemical pulse. Lastly, some of these remarkable microbes leave behind layered records like nature's version of an Instagram feed, capturing snapshots of ancient environments. Layer upon layer of microbial mats build up in shallow waters, preserving historical data about oxygen levels, salinity, and more. When these layers harden into rock, they become time capsules of eras gone by, allowing scientists to unravel the mysteries of our planet's past. They provide a fascinating glimpse into shifting coastlines and fading climates, revealing the intricate web of life that thrived long before complex organisms took their first steps on land. These tiny archives are like living diaries, patiently chronicling the memories of worlds that once flourished beneath the waves. Microbes have mastered the art of sticking together, creating their own community vibes through sticky biofilms. Picture this. These tiny powerhouses secretively pump out polymers to form protective gel layers, allowing them to cling to surfaces like a determined toddler refusing to let go of a parent's leg. This biofilm acts like a cozy fortress, trapping nutrients and creating a mini world where pH shifts or toxin spikes can be weathered without a hitch. Think of them as tiny plumbing systems that keep the flow of essential nutrients and gases pumping efficiently throughout their environment. As the biofilm gets cozy, it becomes a bustling neighborhood of different species. Like a well-organized community, these microbes occupy distinct turf where they chip in together to process incoming nutrients and tackle waste disposal. This arrangement makes it feel like a team project with a sense of shared responsibility. And just like a group of superheroes, the outermost cells act as the brave defenders, taking the hit from harmful substances to shield their friends buried deeper within the walls of their microbial fortress. When life gets tough, sometimes it's necessary to shift gears. Those crafty microbes break free from their biofilm home and send bits of themselves off into the wild, carrying their unique communities to greener pastures. They don't panic when conditions get dicey. Rather, they create miniature life rafts, demonstrating impressive resilience. These biofilms are incredible, standing firm against physical disturbances and chemical onslaughts, proving that a collective effort can yield a more robust existence than going solo. But hold your applause, it gets even better. Some microbes have a superhero twist. They can change their shape whenever danger comes knocking. When hungry predatory grazers show up, some microbes morph into long, thin filaments, making them look less appetizing than a soggy lettuce. Others puff up like balloons with awkward angles, while some equip themselves with temporary spiky defenses, giving predators a prickly challenge. These quick transformations, prompted by predator cues or vibrations, show that even the smallest organisms are ready to defend themselves with a little creativity. Then there are the show-offs of the microbe world, the ones that swim with flair using tiny whips known as flagella. These spiraling protein threads function like a tiny motorboat, spinning away with impressive gusto. Some microbes boast multiple flagella that work in perfect harmony, while others finesse their way through tough environments like mucus. Flagella movement is not just impressive, it's a fine-tuned engineering marvel, capable of instantaneous direction changes you won't see any overheating here. Temperature regulation is another cool trick up some microbe sleeves. Equipped with unique proteins, they can play it cool literally. These proteins don't just protect enzymes from cooking or freezing, they keep their membranes flexible under temperature swings. Whether basking in a hot spring or chilling in icy waters, these masterful microbes adjust their internal conditions, displaying a sophisticated form of molecular thermostats that ensures they remain active and thriving regardless of the external chaos. In the grand scheme, these strategies highlight the remarkable adaptability of microbes, showcasing that success often lies in teamwork and flexibility rather than brute strength. This vibrant world of microscopic life, with its wily maneuvers and clever innovations, proves that there's a lot more going on beneath the surface than we often stop to recognize. It's a fascinating reminder that even the smallest players have their tricks and talents, making the microbial world a lively, dynamic place to be. Microbial colonies resemble the United Nations of the tiny world, bustling with activity and stunning architecture. Picture towering spires, honeycomb lattices, and tiny, dome-shaped forts forming on submerged rocks and tree bark. No architects here. These structures emerge from the collective efforts of countless microorganisms, each chatting via cheeky chemical signals. As they divide, they coordinate their movements like a microbial flash mob, deciding when to clump together or stretch their boundaries to build supportive frameworks. The buzz in these colonies is all about nutrients. Their infrastructure is like an all-you-can-eat buffet, where the availability of food influences how they act. If there's a nutrient party nearby, they gather round, changing behavior and adjusting their designs for maximum efficiency. Meanwhile, these impressive structures channel water, trap essential minerals, and create cozy little niches for new microbial tenants. Over time, what began as a small gathering transforms into a busy micro-city with intricate chambers and ventilation systems, all tailored for their specific microbial needs. And when the universe shifts, guess what? These microbes pull a makeover. Tired of their old gig? They remodel their layouts and adapt their designs to fit new circumstances, like tiny architects ready to redecorate. But the fun doesn't stop there. Some microbes are the wizards of nature, producing surfactants that could rival any man-made chemical in their capabilities. These surfactants reduce surface tension, making water act like it downed a double espresso, spreading and soaking in ways that shake up the status quo. Imagine water droplets morphing into tiny superheroes, carrying nutrients wherever they travel. It's not just about getting hydrated. These microbes are re-engineering water behavior, some even using tiny emulsions to trap energy-rich food particles. In muddier environments, they show their skills by breaking down gunky oils and shattered waxes, transforming the ecosystem one microbial modification at a time. It's like a molecular makeover that not only influences local chemistry but also orchestrates the fate of entire microbial communities. Not all microbes like to hang out solo. Some are the ultimate freeloaders, living it up inside insects like beetles, aphids, and termites. Nestled within specialized tissues or cozy gut chambers, these little roommates feast on their host's leftovers. In exchange, they whip up essential nutrients to keep their insect buddies happy and healthy. But that's not all. Some even have a knack for detoxifying plant defenses, turning potentially harmful leafy snacks into viable meals for their insect hosts. The evolution of these relationships is palpable. Insects and their friendly microbes have co-evolved to the point where they are interdependent. Some microbial guests even control significant factors in their insect roommates' growth, maturity, and reproductive success, proving that sometimes it's the quiet collaborators that play the most vital roles. Turns out, our buzzing friends owe much of their success to this microscopic entourage living within them. Let's not forget the bravest among microbes, those that thrive in minuscule droplets of water. Picture tiny worlds within droplets, clinging to leaves or nestled in soil grains. This jewel-like universe may hold just a whisper of carbon and minerals, but it's more than enough for certain bacteria and protists to live full lives. They strategically divide, compete, and even die within these microscopic bubbles, relying on elite survival skills to thrive in such skimpy spaces. In this realm, every crumb of nutrient is a feast, and every moment is a chance to scavenge for that next little life-sustaining morsel. When tiny droplets collide, or when the last rain of the day evaporates, it's like a thrilling party mix for microbes. These pint-sized organisms thrive in their self-contained habitats, showcasing that life didn't need the grandeur of lakes or puddles to get rolling. A mere whisper of moisture creates bustling ecosystems where predators eye their prey, all while executing complex chemical transactions that rival even the busiest stock exchanges. Who knew that these miniature communities didn't need a formal invitation to exist? Among the microbial guests are some of the tiniest living creatures, whose genomes are skimpier than your average virus. Imagine a bug with a suitcase so small that it can only fit the absolute essentials. These bacteria have baseball card-sized genetic instructions that cover the basics of metabolism and replication, showcasing a remarkable knack for extreme specialization. Living primarily in the cozy confines of animal mouths or cozy underwater nooks, they depend on their nutrient-rich surroundings, having given up producing most compounds on their own. Their tiny genomes house a complex cellular machinery that can respond to their environment like a hyper-aware friend paying attention at a dinner party. Let's throw shade on viruses, shall we? Sure, they may flaunt their small genomes, but they're like freeloading party crashers that absolutely rely on hosts to replicate. In stark contrast, our minimalist microbes maintain their independence, smartly navigating the challenges of survival on their shoestring genetic budget. They raise a red flag for our conventional wisdom about the DNA life really demands. It turns out, less can indeed be more. Who knew? Speed is the name of the game for some microbes, and under the right conditions, they can turn a single cell into billions quicker than most of us finish our morning coffee. Their secret? Streamlined metabolism and a knack for efficiency that would put even the best hot dog eating champions to shame. Some of these speedy little critters even double down on their genetic material, ensuring DNA replication kicks into gear before the current cell has finished its race to the finish. When they plug in and convert food directly to cellular goodness with minimal energy lost, they dominate nutrient-rich environments faster than you can say microbial takeover. These marvels of nature aren't just doing it for the fun of it. Their swift growth has implications in biotechnology. They become like microscopic factories, cranking out enzymes, vitamins, and other precious compounds. Their speedy conversion rates reveal how life can thrive and expand at an electrifying pace. Who needs slow and steady when fast and furious gets the job done? And here's an eco-friendly twist. Certain microbes excel at capturing carbon as solid minerals. It's like they're little carbon sink factories. By encouraging carbon dioxide to mingle with calcium, magnesium, or iron, they form sturdy carbonates that hang around for decades. These microbes engage in this chemistry dance on their surfaces or using enzymes to tweak the local pH. Over time, their expertise builds thick crusts that protect entire microbial mats, contributing to the formation of limestone deposits that serve as natural archives for carbon. Then there are the crafty microbes that take the concept of protection to new heights literally. They've figured out how to form hollow spheres, acting like cozy protective shells that keep their inhabitants safe from predators and toxic surrounds. In freshwater lakes, marine environments, and even the dampest soils, these tiny architects are busy secreting layers that bend into perfectly rounded capsules. This design maximizes volume while conserving resources, ensuring they're well protected against the unpredictable nature of their world. Who knew being small could bring such big ideas? Some tiny residents of the microbial world have a knack for slow dancing. Picture them twirling gingerly within their shells, stirring up a delightful mix of nutrients and waste through their narrow channels. Others take a sturdier approach, embedding themselves in thick armoring walls, ready to withstand any pressure or abrasion. When the universe smiles upon them and conditions improve, these little guys find openings to disperse the next generation, leaving behind neat fossilized spheres that tell tales of their former microbial metropolis. Their architecture is a masterclass in resilience, sculpted solely by biochemistry, needing no blueprints, just the basics of molecular assembly. Now hang on just a moment. Not all microbes are meant to just chill within their cozy shells. Some of them have a burning desire to neutralize nasty ammonia lurking in water bodies. Think of them as the eco-friendly agents in our aquariums and wetlands. These industrious microbes spring into action, transforming toxic ammonia into more plant-friendly compounds. Some initiate a one-way ticket for ammonia to become nitrite, and others turn it into nitrate, which plants just adore. Their fast-paced work keeps ammonia from wreaking havoc in the ecosystem, ensuring aquatic life remains blissfully unaware of any impending ammonia spikes. Among the remarkable tenets of nature are microbes thriving in the dark corners of remote caves. These caverns, heavy with hydrogen sulfide and carbon dioxide, are like an all-you-can-eat buffet for specialized microbes snacking on mineral surfaces. Picture a realm devoid of sunlight, where traditional life forms would be sent packing. Yet, these miniature titans of resilience find a way to thrive. Some may even produce sulfuric acid, etching out new chambers and showcasing their architectural prowess, while others set up shop in low oxygen pockets, creating unique ecosystems that challenge our concept of habitability. And let's not forget the marvelously connected world of microbes. In damp soils and aquatic biofilms, some master communicators extend delicate filaments, forming an intricate web between colonies. Visualize these threads as slim highways for nutrients, signaling molecules, and even electrons, allowing microbial communities to synchronize efforts like a well-rehearsed ensemble. When one connection snaps, the affected colonies can falter, proving just how indispensable these threads are. Over time, these networks morph isolated patches into sprawling, integrated superorganisms united in their shared fate. But wait, there's yet another twist in this saga of microbe greatness. Certain heroes of the microbial realm have taken on the challenge of tackling tough plastics that clutter our planet. Whether in landfills, compost piles, or along pristine shorelines, these fearless microbes gnaw away at synthetic materials designed to outlast a human lifetime. With specialized enzymes in tow, they grab onto those long, straggly polymer chains and slice them into manageable bits. It's as though they were crafting a masterpiece from an unyielding puzzle. So next time you consider the tiny wonders of our world, remember that these microorganisms are not just passive spectators. They are industrious little dynamos altering ecosystems, forging connections, and even tackling humanity's plastic problem. Their cleverness knows no bounds, as they call upon biochemistry to create, adapt, and thrive even in the most unlikely of conditions. The microbial tale is one of resilience, cooperation, and surprising brilliance in the everyday dance of life. Once the plastic menace is broken down into its smaller, more manageable bits, it embarks on a grand metabolic adventure. Here, a distinguished crew of microbes steps in, forming a diverse recycling team. Some specialize in devouring polyester-based plastics, while others take on polyurethane, which seems to have settled in for a millennial-long stay. Under the right conditions, think cozy microbial soirees, these critters work their magic, softening stubborn plastic films until they crumble into a more digestible form for fellow recyclers. It might not be the speedy turnaround we see in nature's organic breakdowns, but hey, evolution is in the business of surprises. In the grand scheme of soil, we often overlook the real architects underfoot, the extraordinary microbes. Most folks picture dirt as just a hodgepodge of sand, silt, clay, and a sprinkle of organic matter. But it's more like a tidy little party, woven together by microscopic maestros. Bacteria and fungi join forces, secreting sticky compounds to form stable aggregates. This dynamic duo prevents erosion and helps soil hold water while creating those essential little pores for air and moisture. It's a bustling underground world where rodents mingle, seeds take root, and life flourishes, all thanks to the diligent labor of these tiny soil ninjas. These industrious microbes also have a reputation for playing with the atmosphere in ways we might not expect. In the lush realms of wetlands, oceans, and forests, these microscopic powerhouses are busy producing gases as natural byproducts of their inner workings. Some of them are carbon-based gas artists, while others are nitrogenous innovators who influence cloud formation and even rainfall. In low-oxygen party zones, archaea unleash methane, albeit while others eagerly intercept it before it can float away into the atmosphere. This constant exchange ultimately shapes our climate and air quality, turning microorganisms into unsung heroes behind environmental scenes. Adding to their list of talents, some microbes are like nature's own electricians. Imagine certain bacteria working tirelessly to create electrical gradients around their tiny selves, emitting faint but detectable fields into their surroundings. By carefully juggling charged ions or releasing molecules packed with energy, they set the stage for an electrical ballet. These electric whispers influence the behavior of neighboring cells. Some are drawn to the signals, while others change their vibe according to the local electric landscape. In biofilm communities, interlinked fields send messages that keep everyone on the same rhythm as they face shifting resources and environmental challenges. This electric communication showcases nature's knack for developing fine-tuned systems long before we humans decided to pair wires and circuits. Within these buzzing microbial societies, living electrical systems act as a form of communication that goes beyond the chemical signals we're all familiar with. It's a remarkable blend of versatility and intelligence, creating an intricate network where cinching responses and guiding movement happen seamlessly, ensuring no microbe is left out of the action. So next time you stroll through a garden or kick up dust on a trail, remember there's an entire underground world of microbes orchestrating the ecology above. Those unseen forces are constantly shaping our soil, filtering our air, and recycling waste, working together with finesse to maintain balance in the ecosystem. It's a wild, interconnected web of life where tiny players hold the reins to larger environmental outcomes. Who knew nature's backstage pass would be so captivating? In the battle against microbes, there's a remarkable group that laughs in the face of sterilization. While hospitals, labs, and factories deploy their best cleaning tactics to wipe out every germ in sight, some of these tiny warriors just sit back and chill out. They can enter a restful state where their metabolism hits pause, toughening their skins and dehydrating their membranes to ride out the chaos. When UV light and harsh disinfectants come knocking, they get a bit singed but not destroyed. Instead, they repair their damaged DNA like pros, reassembling their genetic puzzle once the coast is clear. Talk about resilience. These microbes aren't just survivors, they're ingenious energy manipulators. Forget about fancy plants soaking up sunlight and transforming it into sugars. Some microbes have mastered the art of snagging sunlight and turning it straight into heat. Armed with special pigments, they capture photons and release energy as warm vibrations. This nifty trick helps them thrive in chilly waters while jostling for position in shaded spots. The warmth they generate creates a cozy mini biome, perfect for letting fellow organisms share the good life. Who knew a bit of sunshine could feel like a spa day for microbial life? Speaking of cozy habitats, let's dig deeper underground, where ancient microbes thrive in total isolation, munching on the simplest snacks Mother Earth has to offer. Deep within crevices of our planet, where time stretches like a fabled tale, these microbes feast off hydrogen, methane, and sulfate, enjoying a slow-motion life. While surface creatures rush about, these little ones are casual, dividing only once in what feels like geological eons. Their endurance reveals a surprising truth. Life can exist far from sunlight and fresh air, thriving instead on the chemistry of rocks and minerals. Astonishingly, these subtle microbes also share an incredible partnership with corals that form vibrant reefs. Nestled within coral tissues, these pixie-like photosynthetic microbes whip up nutrients that help the coral thrive in sunlit waters. While they're busy turning sunlight into sugar treats, corals reciprocate by providing shelter and essential nutrients like nitrogen. This brilliant teamwork brings to life the stunning hues and towering structures of coral reefs, proving that friendship is vital for a healthy ecosystem. However, this friendship has its challenges. When the temperature rises, corals can turn on their partners and send them packing, leading to coral bleaching, a disaster for the reef. But don't fret too much. When conditions become favorable again, this symbiotic relationship can be rekindled. Some special microbial strains even step up to bolster coral resilience, churning out antioxidants and stress-relieving compounds to help their coral pals bounce back from the brink. This intricate dance of exchange between microbes and corals showcases a thriving interdependence. It's a relationship that illustrates not only the fragility but also the tenacity of life. As we continue unraveling the mysteries of these tiny helpers, we're left with crucial insights on how life thrives in all sorts of unexpected spots and conditions. From deep rock dwellers to sun-kissed coral partners, these microscopic marvels remind us just how crafty and resourceful life can be. Coral reefs, often labeled as massive animal structures, owe their very existence to the tiny unseen heroes residing within them, the microbes. These microscopic pals play a crucial role in shaping our climate by orchestrating chemical reactions that release or consume gases impacting global temperatures. Within the vast oceans, these planktonic influential figures produce compounds that dance into the atmosphere, forming cloud droplets that play a part in cooling our planet by reflecting sunlight. Who knew such tiny creatures had such a knack for climate control? Digging deeper into the ground, we find unsung microbial decomposers working diligently in the soil. These pint-sized powerhouses regulate how carbon dioxide makes its way into the atmosphere, speeding up or slowing down the decay of organic matter. Meanwhile, in the wetlands, a wacky partnership emerges, as archaea produce methane while their microbial buddies gobble up some of it, striking an intricate balance that moderates this potent greenhouse gas. Even in arid deserts, these industrious microbes play a role, affecting carbon absorption on rocky surfaces. Now, let's venture into the world of mining. Believe it or not, a select group of microbes can extract precious metals like copper, nickel, or even gold from ores without breaking a sweat or sending a mining truck rattling through the landscape. These crafty little organisms adhere to particles and release acids that dissolve tightly bound metals, effectively turning rocky wastelands into gold mines. By avoiding high temperatures or harsh chemicals, these microbes perform a delicate dance of extraction that shows just how savvy and resourceful they can be. Speaking of globetrotters, some microbes have proven to be exceptional travelers, soaring on dust across continents. When vigorous winds stir up dust from the ground, these minute hitchhikers rise up, clinging to clay and organic matter. High in the atmosphere, life is tough, but many microbes enter a dehydrated state that acts as a protective shield against the brutal environment. It's like they're packing for a long journey, ensuring their DNA and proteins remain intact as they float upon the winds, eventually falling back to Earth when it rains or snows. When these airborne microbes land, the first droplet of water can awaken them from their slumber, kickstarting their metabolism after possibly traveling thousands of kilometers. Their global adventures influence microbial communities far away from home, shifting soil fertility and affecting plant health. They even have an impact on the chemistry of clouds at high altitudes. Who knew tiny life forms could traverse the globe and alter ecosystems in such remarkable ways? Beneath the surface, another spectacular alliance takes shape between plant roots and specialized microbes. This extraordinary symbiosis thrives just where the action is, near root tips oozing sugars and organic acids that attract beneficial microbes. Once they settle in, these tiny allies work their magic, producing enzymes that break down nutrients in the soil, making them easier for plants to munch on. It's like having free nutrients delivered right to their doorstep. Some microbes exhibit superhero-like abilities, helping plants endure tough conditions. They facilitate nutrient absorption, solubilizing phosphorus and capturing trace metals, always looking out for their leafy friends. Certain species even offer resilience against drought by promoting thicker root walls or releasing special compounds to reduce water loss. This intricate dance of collaboration between plants and microbes showcases the joys of working together and how even the smallest beings can make a massive difference in the world. In the bustling underground world, plants have a best-kept secret. They've got a thriving relationship with the microbial squad living in their roots. These tiny fellows don't just hang around for kicks. They offer a smorgasbord of nourishment, creating a cozy, nutrient-packed haven below the surface. Whenever the going gets tough, whether it's salty soil or extreme temperatures, these microbes jump into action, softening the blow and deciding whether those eager seedlings will strut their stuff or wither away. Talk about an underground alliance. What's even cooler? Some of these crafty microbes whip up protective mineral shields. Picture this. In steamy hot springs or murky depths, they absorb dissolved ions from the water, which they then transform into crystalline shells. The thickness of these shields can vary, from dainty layers to formidable armor. The magic starts at the microbe cell surface, where organic molecules orchestrate a symphony of mineral growth. As more and more ions hitch a ride, the shell becomes a sturdy fortress, defending the microbe against predators and environmental chaos. But wait, there's more. Microbes aren't just about defensive tactics, they also engage in good old-fashioned warfare. Some species have developed the knack to munch through rival biofilms, those slimy fortresses that shield microbial communities from harm and dehydration. Armed with enzymes that dismantle the sticky polymers binding rival cells, they leave a path of exposed, vulnerable microbes in their wake. Talk about a hostile takeover. This ongoing battle for prime real estate shapes the microbial landscape, influencing which species rise and fall in dominance. Even in the game of survival against viruses, some microbes take a unique stand. They produce natural antivirals that act as a protective cloak for their communities. In tightly packed neighborhoods, these smart little guys secrete molecules that stop viruses from attaching to their surfaces or mess with their replication processes. It's like having a bouncer at the door, ensuring that only friendly microbes get in while the nasty viruses are booted out. The result? Happy, thriving communities, while the unprotected others struggle to survive. Perhaps most fascinating are the microbes that call dark, deep-sea creatures their home. In those frigid depths of ocean trenches, giant tube worms and clams rely on their microscopic tenants to convert toxic chemicals like hydrogen sulfide into much-needed organic meals. Imagine the culinary magic happening in the deep. These microbes are the ultimate team players, taking what would be harmful elements and transforming them into a buffet for their hosts. As researchers continue to unlock the secrets of these microbial interactions, it becomes clear that these tiny beings are anything but boring. The intricate web of relationships among plants, microbes, and their environment showcases a world where each player contributes to the thriving ecosystems in ways that are both cunning and elegant. The tiny drama playing out beneath our feet is certainly worthy of a blockbuster script. Deep beneath the waves, a fascinating partnership unfolds. In this undersea world, animals have teamed up with marvelous microbes that turn chemicals into life-sustaining resources. Instead of munching on traditional snacks, our deep-sea friends thrive in dark waters where the sun doesn't shine. These microscopic marvels adjust their metabolic pace, cranking up productivity when their hosts are on a growth spurt and hitting the brakes during tougher times. This wacky teamwork is a standout feat of evolution. But that's not all. Some microbes are like tiny geological artists, sculpting their environments with a chemical chisel. In soils and caves, they're busy crafting intricate designs by releasing acids and alkalis, which dissolve some minerals while crystallizing others. Over time, they've turned bland rock faces into textured landscapes. Caves become galleries filled with microbial masterpieces. Even in the soil, their handiwork helps determine how water flows and where nutrients hang out, talk about impressively altering the scenery. Imagine a world where some microbes can transform in the blink of an eye. While many critters need eons to adapt, these tiny guys can shift gears with astonishing speed. When faced with fresh nutrients or tricky toxins, they flip their gene expression patterns as if they have their hands on a high-tech control panel. By cranking up protective proteins or remixing their metabolic pathways, these speedy microbes colonize new habitats before the competition even knows what hit them. Size doesn't matter for these microscopic wonders. Some are so minuscule that a single larger cell could cradle colonies of them. Picture bacteria smaller than ribosomes, crammed with essential molecular gadgetry. Despite their pint-sized stature, these microbes are the life of the party, metabolizing and responding to the world around them with pinpoint accuracy. They can hitch a ride on bigger organic friends, or float freely, forming cloud-like colonies in nutrient-rich waters, a true microbial marvel. The effect of these wee microorganisms doesn't stop at mere survival. They can actually reshape ecosystems. From lush coral reefs to vast ocean basins, microbial communities work tirelessly to regulate nutrient cycles and soil vitality. They decide whether carbon hangs out in sediments or goes out to mingle in the atmosphere. Not to mention, they get the plants and animals sorted through intricate symbiosis, essentially guiding evolutionary paths for larger organisms like a pro backstage manager. As we take a step back from this microscopic journey, let's reflect on the silent warriors shaping our planet. These unseen forces weave the very fabric of our ecosystems, balancing the chemistry of forests, oceans, and soils. They remind us that even the tiniest beings can wield their influence with remarkable power and grace. Knowing they're out there, quietly buzzing along, makes our world feel vibrantly alive. So, as you drift away from this adventure in the microbial realm, take a moment to appreciate the magic of these hidden lives. If you felt a spark of joy or curiosity during our voyage today, why not share the love? Like, subscribe, or leave a thought below. Together, we can invite others to discover this enchanting world too. As night falls, allow the subtle hum of these marvelous microbes to cradle you into a deep, peaceful sleep. Sweet dreams await in the embrace of our unseen friends.